want that box to be in the video?
It doesn't matter. Okay. So the way I ended up doing it is I just did it programmatically rather than using the inflator. So whenever we hit the add button pressed, I create a brand new button using this as the current context. Then I set the text of that button equal to the text from our edit text, and then I programmatically add that view from the button into our values view, which is our linear layout. All right, so this is just not using the inflator to do it. The inflator was trying to be efficient, and we don't want efficiency. We wanted to just...
They were trying to be efficient and not showing the values.
Right.
The same button.
Yep. So the idea here is that, I need to go back to this guy, is that we're going to have a linked list class, and the linked list class is a collection of nodes. For us, a node is going to have a payload. It's going to have a next node. We also are going to have a button. All right. This is the our version of MVC. This is the visual representation of a node in our application. Okay. So let's go ahead and let's build a node class in here. So I'll come up here, we'll right click, I'm going to say new Java class, we'll call this guy node. All right, and node's going to have a private, and we'll have this guy be a linked list of integers. So we're going to say private int payload. We'll have private node next node. And we'll have private button. We'll call that guy view. Okay. Now, when we build a node, it's going to take in a payload and as well as a view. All right, we'll say this dot payload is equal to payload. We'll say this dot view is equal to view. We'll say this dot next node is equal to null. Because when a node first comes into existence, it points nowhere. We go back to our picture here. When I first made this, brought that node into existence, it did not point anywhere. It was not until later on that we actually made it point someplace else. Make sense? All right, so we're just giving birth to this node at the beginning, therefore he currently doesn't point anywhere. We're giving him his initial value. So right here, this is our constructor for a node. So when a node is first born, this is his most basic form. Right? He has a payload, he has a view, a button, because that's kind of how we're representing it in our application. All right? That's how we can see it in the Android app. But he also has a next node, but it currently doesn't go anywhere. We will set it soon. Okay? Then I'm going to go ahead and we're going to create setters and getters for these guys. If I right click here, I'm going to do generate. This is a shortcut thing in Android Studio. So I can go to generate, I can do generate getters and setters. And I can do it for all of these guys. Just hit OK, and it goes ahead and puts those functions in there for me. Yep. Or you can just do getters or just do setters. So it's shorthand, a short way of having all those guys. All right, so we'll leave it in there for now like that. So we'll go back to this guy. So now when we do that add button pressed, instead of creating a button directly like this, we want to, we want to also create a node. So I'm going to do this. I'm going to say node n is equal to a new node. And the constructor for a new node takes in the integer payload, and then it also takes in the button. All right. So I'm going to say this dot new value. Actually, I need to, that guy's a string, so I need to get the integer out of that. So parse int this dot new value et dot get text. Just convert that to a string. Is it gonna be okay with that? Don't like that. It doesn't like me trying to parse the integer. Out of this dot new value et dot get text dot toString. That'll do it. All right, so here's the text that's in our edit text. Here's the string version of it. I'm going to pass that guy to our tool integer.parseInt that squeezes a number out of a string. And we're just going to trust that they entered a real number, you know, because if we try to squeeze a number out of like Mike, it's not going to go well. The program will crash. Okay, and then we're also going to pass in our button that we created. So we won't actually set the text here for that button. We're going to do that inside of our node. So in the constructor for our node, we'll say this dot view dot set text equal to the string version of payload. So we'll just concatenate payload onto the empty string. Come back out here, and we'll say this dot. And actually what I'm going to do, just to keep this cleaner, I'm going to steal that. We're going to replace B there with just new button this, so that way we don't have a B right there. And then right here, I'm going to say n.get view. That's the view we're adding to our values. So I'm going to build a brand new node object. A node object requires me to give it the integer version of my payload, as well as, in our case, a button. Here's my new button that I'm giving him. So this says, build me a brand new button in terms of this activity. Needs a context. Don't worry about that for right now. That's just how you write it. Okay? So this is how we create a new button for our visual scene. And this is how I get the integer version of whatever's in our current edit text. So I'm passing those two values into our node constructor. That guy's stored inside of something called n. I'll then go ahead and add n to our view. Okay, but right now we're doing this pretty generically because we're always assuming we're adding it to the end of our list, right? When the reality is that we're not always adding to the end. We might be adding to the front. Might be adding to the, see how this is going? So we might need to decide how we're going to add that view. Let me check something here. This dot values view dot add. Yeah, so you can add views at index. So we'll write that here in a second.
You have to get the value in like ordered.
Well, we're implementing our simple linked list here real quick. You guys will have to implement some of the more difficult aspects of it, but I'm going to do the simple ones so we can see how the buttons work. So we're not just going to have a just an add. We're going to call this guy front. That'll say front. Then let's go ahead and put another button in there for end. Not going to let me move it. Okay, so we'll have this guy say end. Okay, let's think. So for, yeah, this will give you enough to work on for it. All right, so front and end. So when I add something to the front of the list, it's going to always add something at bucket 0. Okay, when I add something to the end, it'll always add to the end of our linked list. Okay, now right now I've just built nodes. So we have kind of 2 versions of our linked list here. We have what we visually see, right? And then we actually have the linked list data structure, which we haven't actually built yet. Make sense? So we've built the node part of that guy. So let's go back over here. And I'm going to go ahead and I'm going to create our L list. I'm going to call it L list instead of linked list because there's already a linked list built in. Okay, so that's going to be our L list. Okay, an L list is going to have a private node called head. And we're going to have a public L list. This dot head is equal to null. This dot, public void add front, and this guy is going to take in a node n and a linear layout. Call that guy the view, so that we could properly add it to the end. Okay. In fact, actually, why don't we have this guy just take in an int payload, and we'll have him make the node. I think that'll keep it cleaner. Okay, so that'll be add front. So let's go ahead and do the add front. That'll be the easiest one because it's always going to be at 0, right? So what I'll do here is we'll come into this guy. So our we're going to change this to be called add front button pressed. And just so I don't forget, let's go make our guy here match up to that. Okay, and then I'll go ahead and add the on click for this guy. This is add end button pressed. All right, so we'll come back into here. That's add front button press, so I don't need to print that out anymore. This is how we get our, and let me come up here to the top. I no longer need that, so we could just hide that. I'm going to say private linked list, L list. Call that guy the list. This dot the list is equal to a new L list. So that's going to give me an empty linked list. All right, so then down here when we do add front, I'm going to say this dot the list dot add front. This guy's going to take in a payload. What's the payload? The payload is this guy right here. That's our actual payload. That's the integer. And then we're going to pass in the value view. Let's see, what's it called? Values, not the values view. That guy. All right, so we're going to add to the front of our list that guy. So he's going to rely on the linked list himself to do all the adding. Okay. Similarly, This would be add end button pressed. And he's going to do the same thing, except he's not going to call add front. He's going to call add end on our linked lists, which we haven't written yet. So whenever we do this, we're going to call upon our linked list and say, hey, he wants to add something to the front. Linked list, here's the payload he wants to add, and here's our linear layout, the thing that the users will see, so that you could make the visual match up to the list itself. So we'll come over.
Automatically do when we add a new field to the linked list in the front, so we have.
But I'm doing it here. Yeah, we're doing the whole linked list stuff inside the linked list. So the linked list itself is going to create the linked list structure, which we're about to do, and it'll also make sure that our linear layout looks correct. That makes sense? Make sure it looks right. So here's our add front.
So it will automatically add the pointers to the next.
Well, not automatically. We're going to write it so it does it right. Add end. Okay, so add front. What do we need to do? We need to create a new node. Okay, but in order to create a node, we need a button. Okay, so we're going to need a button. Actually, we'll do it like this. We did it before. Node n is equal to new node. And this guy's going to take in a payload. And he's going to take in a new button. Ooh. Need to import button. I don't think view is an acceptable context. All right. So let me go back here and pass in the actual context. All right, so I'll create my new node with the payload and my new button, and the button needs to be built in terms of a context, so I had to pass my activity in here in order to build it. That's all we're using it for. So just use my code and it'll work. So there's my node. Now I want to add that node to the front of my linked list. Okay, so let's think about how that works programmatically for our linked list first. Okay, so initially, I'm just going to steal one of these guys here. And I'm going to delete the rest of this linked list. So initially, my linked list looks like this pathetic guy down here, right? It's got a head that points nowhere. Okay, so I want to add this brand new node here to the beginning of my list. So if head is null, then I just want to make head point to this guy, right? All right, so that's the simple case. So if head is null, just make head point to that guy. So we'll say if this dot head is equal to null, then this dot head is equal to n. Make sense? All right. Otherwise, if head already points to something, so for example, just give myself a second guy here, and here that's memory address 212, and that's the number 9. So if my list currently looks like this, and I'm adding something to the front, in the end I want my list to look like point to here, then this guy points to here, right? So I need to take my my new node n, and I need to set his next node to point to the same place head points to. Then I can set head to point there. I can't go the other way, otherwise I've lost my pointer. If I do this right off the bat, if I have my new node here, and that guy points to null, and the very first thing I do is I change head to point to my new guy, this guy's lost. It's just floating out there. That makes sense? So it's very important that we do it in the right order, which is why drawing the picture is important. Okay? So the very first thing I do is I'm going to take my brand new node n, and I'm going to make his next node point to the same place that head points to. Okay? So we're going to say n dot set next node to this dot head. Make sense? That's what that guy does. Then, once I've preserved that, once I have it looking like that, then I can say head now equals this guy. This dot head is equal to n. Okay? So now I've added it to the front of my list. Structurally. So now my linked list data structure behind the scenes is correct. Now I need to make sure my view looks right. Okay? So that means I need to take that node and I need to display it at the top of my view, right? Because it's always going to go, it's going to be the first guy on the list because I'm adding it to the front. Okay, so no matter how I ended up adding it up there, I need to go ahead and I need to say view, which is my linear layout, dot add view at a specific index. The view I'm going to add is n.getView, and I'm going to add it at index 0. That make sense? Okay. Now, something that'll be helpful for us. Up here, my linked list, I'm going to teach my linked list to count how many elements are in it. And you'll see why this is helpful in a second. So when a linked list is first born, its head points to null and its count gets set to 0. All right, that's the baseline of it. Now, after I've added something to the front, whether it added in this if or it added in this else, I can say this dot count plus plus. It's got one more thing in it, right? So now that count variable always keeps track of how many things are actually inside the list. Okay? So that's add front. Add end, I'm going to do something similar. So let's steal the code and then we'll modify it. Okay, this guy is going to take in a context just like we did up there. So I'll create my new node. If my head is null, just add it, right? No harm, no foul. Because then the end and the beginning are the same thing. It doesn't matter. Otherwise, what do I need to do? If I have a list that looks like this, and then I have a brand new guy I want to add. So this is memory address 400. This is the number 13. It doesn't matter where we have them laid out here. So now I want to add this guy to the end. Well, right off the bat, we see that head's not equal to null, right? So how do I get to the end of my list?
By getting the address of that thing. Start from the head, traverse to the end.
Yep. So I go here to here, then here to here. So I keep walking until when? How do I know I'm at the end?
Now, the last one.
The next node is null, right? And we know that's the case because when we first built nodes, we made sure we initialized the next node to null. All right, so what do I need to do here for add end? I need to find the last node. So I'm going to say cur node is equal to this dot head, while curnode dot get next node is not equal to null. Curnode is equal to curnode dot get next node. So we'll start curnode pointing at the beginning of the list because we don't want to change head, right? All right, so we have a brand new guy here called curnode. And kernode currently points at head. So now we say, while kernode dot get next node is not equal to null. Does kernode currently have a next node?
No.
Here's kernode. Kernode's the same guy as this guy. Does he have a next node?
Yes.
Yes, he does. Okay. So actually, hold on. Let me draw the better picture here. That's actually what we look like at the beginning. We say kernode and head both point to the same place. Does kernode have a next node?
Yes.
The answer is still yes, because this guy has a next node. His next node is something other than null. Therefore, we're going to set kernode equal to his own next node. Then we loop back up. We ask it again. Does kernode have a next node?
No.
He does not. So we know at that point kernode is pointing at the end of the list. Therefore, we can then set kernode's next node to our new guy. So we'll say kernode dot set next node to n. Make sense? And in either case, we'll always increment our count by 1. So now we know we have one more thing than we used to have. Okay? But now we need to add him to our list. Now, we happen to know that add view always adds it to the end. We've seen it happen. Okay? So I actually just have to do that, and they'll add it to the end. Make sense? Okay. And our linked list behind the scenes should remain true. So let's see this happen. And I want to do one extra thing here in my main activity. After we do an add front or an add end, I want to say this dot, well, we'll just clear it. This dot new value et dot set text equal to the empty string. Let's just clear the box just so it's kind of prepared for us to put in another value. Okay. All right, so here's our initial list. There's nothing in there. So we'll go ahead and say, here, we'll just count. So we'll say 1, and it doesn't matter if we add this to the front or the end. So there's our front. Now if I add 2 to the front, it should put it before that 1. Okay, if I add 3 to the end, it should put it after that 1. Gotta see how that's working?
Yeah.
All right. So now we're able to kind of stack things on our linked list. And, you know, we should be able to, so, you know, we can keep just doing add end. Oh, don't click out of order. I tried to add the empty string, and then I tried to do integer.parseInt of the empty string, which isn't a number, and that's why it crashed. So our code is fine. We just didn't check for errors. All right, so that guy seems to be doing the stuff all right. All right, so now what I'm going to do, have any of you ever used a tool called Github? So source control.
Yeah, it comes between sides so that you can jump to the side. And there it rotates you, right?
So here's the website for it. It's called github.com. All right. What I'm going to do is I'm going to go ahead and I'm going to deploy my code to GitHub. And when you do your homework assignment, I want you to put your homework assignment on GitHub and then submit me a link to your homework assignment. All right. So what I'll do is I'll post a tutorial for using GitHub, but I'm going to show you how to do it. Okay, right now. So you're going to get the quick version of it, but then there's tutorials you can follow for it. Worst case is for this first assignment, you can just zip up your project and upload it to Blackboard. Okay, but GitHub's a good tool. So if you guys are going to work together, he can help you do it. All right. So what I'm going to do here, and you can do this right from Android Studio. So I'm going to go up here to VCS. So this is source code control. So we're going to go to import into version control. So this is the very first time I'm doing it. And I'm gonna share project on GitHub. All right, so it's called 2016 linked list of whatever, CSC537. I think I have it in there. So I'll go ahead and hit share. It's showing, it's going to already select all the stuff, so it's automatically clicking everything it needs to click for the project to go on GitHub, and this is the initial commit. We hit OK.
It is already committed.
Yep. Shared on GitHub. So I'll refresh it here. Let's see, here's our new guy there. So there's my project. So for me, when I'm grading it, I'll be able to click on the app. I'll be able to click on source. I'll be able to click here. And actually, that's the wrong thing. I'll be able to click on main. I'll be able to click on here. And then I can see your code. So I'll be able to look what you have here and so on and so forth. That makes sense? Now, for you guys, what you'll do when you go to check out this code, this is the main page for this application. All right, and I'll go ahead and I don't think, have I gotten you guys on Slack yet? All right, do this as well. So you want to go to website cuwcs.slack.com, and you want to go ahead and no, you're not creating a new. You want to join an existing team. So you're going to put in your let's see. Yeah, this is what you want to do. Is you want to do create an account. If you already have a cuw.edu email address, you want to create an account. You'll put your email address in here, click create account, it'll have you put in a password, and that will ultimately log you into Slack. Slack is available for your smartphone, it's available for Mac and for PC, it's available on the web page. Okay, so it's kind of a chat room that we all are able to use. So I can now, once you guys are on Slack, I can just post the code there in Slack and you guys can grab it right from there. So it's a quick way for us to communicate, for you to ask questions and that kind of stuff. So get on Slack as well. I'll also put this up with the assignment for this first time since we're not definitely all on Slack yet. But to go ahead and let's say you guys are just sitting down to work on the project. I'm going to go ahead and close this. I'm still in Android Studio though. I'm going to say import project, checkout project from version control. So when you first open up Android Studio, you'll click on that. You want to choose GitHub, and you want to put in the repository, so that link I gave you, and you could tell it where you want to check it out to. So the default is going to go to the desktop, so it's going to download my project into a folder on your desktop for you to work in. So when you hit clone, you're getting a copy of it, so it's passed by value. All right? So you're getting a copy of that guy. All right, you have checked out that guy from version control. Do you want to open it? I'll go ahead and say yes. I think this is one of those things that kind of commonly happens. Let me close this here. I'm just going to go and this is one on the desktop. Yeah, so I checked it out. I'm going to just reopen it from the desktop. So want me to create a so there's my code. Let's make sure it'll still launch. Yeah, there's like a weird error thing with checking it out, where that first time you open it, it gives you like a funny error. Just close it and reopen it, and it tends to go away. So there's our thing running from my code. So you guys will be able to do that same thing. So just watch the last couple minutes of the video, and you can get on Slack and get the stuff. So what you'll do is you'll make modifications to this for your homework assignment. Having said that, your impossible homework assignment, let's talk about that for a minute here. I know we're over time, but I guess deal with it. Oh, he does?
Yeah, but he already in last class said this class is going to go to
No, we won't go that late. Okay, so next homework assignment's up on 537 under assignments. Report 2 is write a 2 to 3 page paper talking about the stack data structure in terms of how it works, what its specific functions are. That's going to be push, pop, peek, blah, blah, blah. So it tells you what to write. So stack is going to be our next data structure we're going to talk about next week. All right. Now, program 2. So implement your own linked list, which we've already started that, and actually most of what we have is what you'll need for it. You might need to add some functionality to it, but I think for the most part, you're okay. What you'll need to possibly add is putting stuff in the middle, adding at a particular index in there. Okay? So implement your own linked list. You have to write your own. You can't use the one built into Java is what this next thing says. Then you're going to implement a class called huge integer. All right, so one limitation we have with the integer class in Java is that it can only hold numbers up to 32 bits, which means it can only hold values between negative 2 billion and positive 2 billion. Well, if you want to do math with larger values than that, you need to work with a larger, you need to be able to represent larger values. Earlier you were talking about pi to some number of decimal places, right? So we want to be able to represent arbitrary size numbers. Doesn't matter how many bits they are, okay? You cannot use the built-in big integer class in Java. You have to, we're writing our own big integer, all right? Huge integer is our version of Java's big integer, all right? So you can only use tools we have introduced in class, and you may not use Java's big integer class. Your implementation should support the creation of only positive huge integers, so you don't have to worry about negative numbers. So you're basically going to hold a linked list of a whole bunch of digits. So like the number 127 as a huge integer would be a 1, which links to a 2, which links to a 7. Make sense? Okay. Let's see. You should then be able to add positive huge integers together, producing a new huge integer. So a huge integer in and of itself is a linked list. Okay, it's a linked list of digits connected to each other. We already have a linked list capable of holding integers. But now what you need to do is you have 2 linked lists. You need to be able to add those guys together. So you got to think about how does math work. I need to take this digit and this digit, add them together. Here's the result. There's possibly a carry. Add these guys together. Here's the result. There's possibly a carry. So you're doing math by hand. Make sense? This is only for addition. And it's only for positive numbers.
There will be 2 linked lists, so we have to add the values of 2 like AND node to each other, then whatever is the carry.
As an example, $127 plus 34. Okay, now I'm going to give you a hint here. You might pad that guy out to be the same length as the one above it. If this is a huge integer, 127, and this is a huge integer, 34, you should produce 7 plus 4. Here, I'm going to just give you placeholders here. 7 plus 4 is what? Okay, it's a 0, carry the 1. 3 plus 2 is 5, plus 1 is 6. 1 plus 0 is 1.
7 plus 4 is 11. So
oh, well, there should be a 1 here. Yeah, sorry. 7 plus 4 is 11, so we have the 1, carry the 1. Then 1 plus 2 plus 3 is 6. So 161 is your result. Does that make sense? What I'm asking you to do?
We're having 3 nodes over there. One of the nodes stores 1 in there, and
No. This guy is a huge integer,
that's just one
which
node.
is effectively an L list.
Linked list, 1 linked list.
Okay.
Yeah, so in that linked list, 1 to 7 are 3 nodes.
Yeah, 3 nodes. This is 3 nodes in one linked list. Here's 3 nodes in another linked list.
So you want
You should
the
then add those 2 linked lists together, producing a new linked list.
So if
That is a huge integer, which is going to be an L list.
So if we are adding 0 to the other linked list,
You don't have to. I just suggested you might. That's a
we
hint.
have to add that.
Add to the front.
node.
Add to the front. Here, I'm going to say a sentence out loud that you'll want to review when you do your homework. Notice that I said that I would probably pad this with a 0. Figure out which of your 2 L lists has a lower count. Remember we added a count variable? Take the one that has a lower count and add zeros to the front of it until their count matches. Now you're guaranteed that both numbers are the same length.
Yeah.
Make sense? Okay. So draw lots of pictures. This isn't as hard as it probably sounds.
We need to have only 2 lists.
Yeah, and give me some sort of simple interface for it. This is more about manipulating linked lists, not creating some amazing Android application that allows you to accumulate 4,000 numbers. So you could have, if you want to take your what you learned on the your tutorial where you have a couple of screens, maybe screen 1 has you enter in your first huge number, screen 2 has you enter in your next huge number, then you hit add, and screen 3 shows you the summed number. That make sense? Okay, so that's the Android component of it, the view part of it. I care from a computer science perspective more about the linked list logic behind the scenes, your algorithm for making these linked lists add together. Okay, so I don't really care what your interface looks like. Just slop something together that get you used to doing Android-y stuff and go from there. Make sense? Okay. It would be a lot harder if you had to handle negative numbers and you had to do more than just addition. So this is the easy version of the assignment. It's going to be challenging. It will take you time to do, but you should hate me but not completely loathe me at the end of the All right. Questions, comments, concerns, bribes. Now you got to come up with a better bribe than that. All right.